Hello students, welcome back to my channel NJ Math World. Today I am here with you to explain BCA. First chapter unit 1, the foundation. So this first unit I have divided into two. This is video 1 for the first chapter and video 2 will be uploaded very soon. So yeah, we are going to discuss in the first semester BCA SCP syllabus computational discrete mathematics. Lecture 1, unit 1, chapter 1, the foundations. So yeah, this paper is for 80 mark and you have 20 mark for internal. So in this paper, we'll be having five units. In that five units, I'm starting with the first unit, and the remaining four unit also will be uploaded in my channel. So subscribe and watch my channel to have to get the notes of other chapters as well. Okay, so we are going to explain. I'm going to explain you today what is the basic concepts of a foundation, that is preposition, truth table, connectives, and compound preposition, implication, by condition of non of connectives, converse, inverse, contrapositive of an implication, tautology, contradiction, logical equivalence, application of prepositional logic, and prepositional equivalence. So these are the topics which we are going to cover in our top chapter. So yeah, as I said, you this chapter is divided into two videos. This is my first video. You can just watch this full video to understand the concept in a clear way. So here the questions will come from this whatever I have explained in this unit. So yeah, what is discrete math? It is discrete math is a study of a mathematical structure that are fundamentally separate or distinct rather than continuous. If the function is not continuous, it is called as discrete. The other way he says, discrete maths is a maths of counting countable things. When we count any step, when we count choices, when we count pattern of clothes or vessels or birds, anything that does not follow but jump is called as discrete math. Then we have many applications for that. So then comes the application of discrete math. Why we should study discrete math and what are the application? In future, you can select any one of this application and you can become a specialist in that. You can get a job in this fields if you study discrete mathematics. Okay, so yeah, what are the applications? Let us look on it. So yeah, we have the first one is computer science. Computer science is in computer science. It discrete math helps in writing the algorithm, data structures, cryptography, and programming logic. All this is heavily used on discrete math. This is why it is a main part. It plays a main part in a computer science. Then it is used in cryptography, used to design secure communication system through number theory and modular arithmetic. So it is used in cryptography. Then network design, graph theory helps in model and optimize computer, road, and social networks. So this are some applications where maths is used to in daily life. Okay, then yeah, next we have database system. In this database system, set theory logics are used to process the data and organize the data. Then artificial intelligence, logic, probability, and combinatories support this in making decision and machine learning models. Then software development, automata theory, and formal language is used to compile and design the languages. Then operation research, it is optimizing of problems and used in discrete math in scheduling, logistics, and resource management. Then you have cybersecurity. Here, hashing, encryptions, and secure protocols are used to write the concepts in the number theory by using number theory and combinatories. Then digital circuit design. We use Boolean algebra as a backbone of designing and analyzing the circuits. It is used to analyze the circuit and it is a places and backbone for the designing. Then you have next is game theory. What is game theory? Here, game theory we use maths for strategic design making models are built on combinatories and logic. By using logic and combinatory, we use we use to we can make a game theory. Now, next comes the logic. What is logic? Logic is nothing but magic, right? Okay, what is logic? Logic is nothing but it is a science of reasoning. Reasoning. When you are able to say any reason, it is a science of reasoning. Logic is always magic, right? So yeah, we have science of reasoning is nothing but when logic helps in this distinction between valid and invalid mathematical statements. It separates it may we can identify whether the statement is valid or it is invalid, whether the statement is true or whether the statement is false by using the logic. It helps in understanding mathematical reasoning. So how to give a reason to mathematical statement? It is used to design computer circuit, computer programming. Then it helps in verify program corrections. It helps in program correction. uh, the logic which deals with preposition is called as prepositional logic. First person who discovered logic was George Bully from British. Hence, the mathematical logic is known as Boolean logic. So this was called by his name. So it is called as Boolean logic. Then you have preposition. What is a preposition? Preposition is a very important concept. It is asked in your question paper. So you just have to remember the definition. What is it? A preposition or a statement is a declarative sentence which is either true or false, but it cannot be both. It can be true or it can be false, but it should not be both at a time. For example, I am teaching. I am teaching. So, what a statement I had written might be it is true. It is a true. I am teaching you. So, it is a true statement. So, I am playing. So if it is, it will be false because I'm not playing, I'm teaching you. So it should be true or it should be false, but it cannot be both at the time. Then it is called as preposition. Now, when the statement is not a preposition, we have some conditions. So what are the conditions? Suppose the sentence, whenever the sentences are imperative, whenever the sentences are imperative. What do you mean by imperative? It should be a command or instruction. Then second, it is exclamatory. What is meant by exclamatory? It should have a strong emotion such as surprise, excitement, anger, joy. It ends with the exclamatory mark. Exclamatory mark. Then next one is interrogative. Interrogative, asking questions. It always ends with a question mark. Interrogative. Then it is last is open statement. Open statement. Sentence that contains a variable and cannot be classified true or false is called as open statement. X, Y, A to Z. If you use any alphabet in the statement and we are not able to justify whether it is true or false, it is called as open statement. All of these are not a statement or preposition in logic. So these are the main conditions where you can identify whether the statement is preposition or not. If you have imperative, if it is exclamatory mark, if it is interrogative questions, and if it is an open statement that has variables, then apart from this, all other statements where all other sentences will be a prepositions. For example, you can take example. If they ask you an exam, you can just write mathematical identities are preposition and statement. You can write any one of the formula. A plus b whole square equals a square plus b square plus 2ab, or you can write a square minus b square is a plus b minus b. Anything whichever you remember, you can write that as an example for preposition. Okay, now moving on with this. For each of the below, identify, is it a preposition? S, if S, it is a true or false. If not, if it is false, why is not a preposition? Give reason. So here some questions are there. We'll just have a look of those, how to write the statement and how to write the answers. Yeah, first one. The sky is blue. It is a preposition. Why? It is a true statement. It is a declarative sentence and can be verified as true or false. Sometimes the sky will be blue, we can write true. If sometimes the sky will have different color, we can write it as false. Then second one, close the door. Close the door is a command. It is not a preposition. Whenever it is a command, it is not a preposition. What time is it? It is a interrogative. When it is asked question mark, it is not a preposition because it is asking the question mark. Then 2 plus 3 is 5 is a preposition because it is a true statement. Then x plus 7 is 10. We have a variable x. It is an open statement. Therefore, it is not a preposition. Then moving on with the next one, you have she is a good singer. So she is a good singer. It will be a true or false using that the statement of whom it has been said. So it is a preposition. Do you do your homework now? So it is a command. Do your homework now. So it is not a preposition. Every prime number is an odd number. So it is a preposition because we can say the statement is false. Because 2 we have, which is not a prime, which is not an odd, it is an even number. If it rains, the ground gets wet. Yes, obvious. It is a preposition because it is a true statement. Whenever it is raining, the ground will get wet. Let's go for a walk. It is a suggestion. Let's go for a walk. It is not a preposition because it is a suggestion. So this is how you will identify whether it is a preposition or not. Then moving on to the next topic, we have logical connectives. What is meant by logical connectives? Logical connectives are symbols or words used. It is a symbols or words used to connect two or more statements, preposition in a logic, forming a compound statement. Each connectives have the special rule that determines the truth value or truth of table of the following composition. compound statement. A compound preposition or a compound statement is a logical statement formed by combining two or more simple preposition using the logical connectives. And such as we have here main logical connectives. First one is called negation, where we use not. Then you have conjunction, we use it and to connect them. Then you have disjunction, we use or. Then we have implication, conditional, it is we use if then. Then you have double implication by condition, we use if and only if. So we'll just have a deal, we'll just go through one by one. I'll just describe it one by one what is it. Now moving on to the first one, we have what is mean by truth table. A truth table is a systematical table that shows all possible truth value of a logical expression or a preposition based on the truth value of its components. So now we'll start with the negation. What is negation? In negation, you will be using not, and the symbol will be either this or it will be represented with this symbol. So negation is a logical operator that reverts the truth table of a preposition. So if it is true, it will make it as false. If it is false, it will give it as true. So when you have to reverse this statement for negation. And how do we write the statement for this statement? P, it is raining. So negation will be negation P, it is not raining. We should use not in the statement. Then statement 5 is greater than 3. Yes, it is true. Then what is the negation of this? 5 is not greater than 3. It is false. Then some tips are replace is by is not. We can replace is by is not, all by some not, some by none, or all not. Then equal, not equal will be replaced by equal. These are the words which we can use to negate the statements. Then we have next one is some example. So we'll just quickly go through with the example what they've given. The sky is blue, the sky is not blue. 5 is greater than 2, 5 is not greater than 2. She is a teacher, she is not a teacher. All birds can fly, not all birds can fly. Or we can write some birds can fly. The number 7 is even, the number 7 is not even. X plus 3 equals 5, x plus 3 is not equal to 5. The sun rises in the east, the sun does not rise in the east. This book is interesting, this book is not interesting. No students failed in the exam, some students failed the exam. It is raining today, it is not raining today. So these are some examples for negation. Then I think you people had followed me. We'll move on with the next connective called as conjunction. What is mean by conjunction? Conjunction, we use and for conjunction. A conjunction is a compound statement formed by joining two statements with the word and, such that the conjunction is true only if both compound statements are true. For example, we have what is the truth table of conjunction? It is always P is T and Q is T, the answer is T. When P is T and Q is T, the answer is also T. Otherwise, it is false. Just remember this, when P is T, Q is T, P and Q is also T. Otherwise, it is all false. P, it is sunny. Q, it is warm. We have to join by using and. So, P and Q will be it is sunny and it is warm. True only if both are true. Mathematically, P is 4 is even. It is true. Q, 9 is odd. It is also true. P and Q, 4 is even and 9 is odd. If both are T and T, the answer is also T. So, you can write it in the form of table. P, Q, P and Q. If P is T, Q is T, the answer is T. The next one is some examples for conjunction. So let us quickly read out the sentence for examples answers. Combine the following statements using and. The sky is clean, the sun is shining. What will be the conjunction? P and Q. The sky is clear and the the sun is shining. Then second one, P 7 is a prime number, Q 7 is an even number. What will be P and Q? P and Q will be 7 is a prime number and 7 is an even number. This you have to join by using and. Then write a conjunction statement for it is P, it is Monday, Q, we have a maths class. So yeah, P and Q. What will be P and Q? It is Monday, and we have maths class. So this will be P and Q. They're asking you to negate P and Q. So wherever we want to negate P and Q, we should use not in both this statement. So usually negation of P and Q will be negate the statement is Monday. What will be negation? It is not a Monday. It is not Monday. And negate the next one. We have maths class, so we can write we have no maths class. So this will be P and Q conjunction, and this will be negation of the conjunction. Hope you people are following me. If anything, you can write it in the comment box. I'm here to help you. You can just let me know what are the problems you have and which problem you are finding difficulty. You can just send me. I will help you out how to solve those problems. So yeah, next one we have is determine whether the following conjunction is true or false. So we have to write what is P. P is elephant can fly. Elephants can fly. Then Q. Q will be 2 plus 2 equals 4. 2 plus 2 equals 4. So P and Q. Now we have to write the table for that. P, Q, P and Q. P is elephant can fly. No, it is false. 2 plus 2 is 4. Yes, it is true statement. I said you whenever it is T and T, it is T. Otherwise, it is false. So the answer is false. Now, identify P and Q and form P and Q. Statement 1, the book is on the table. Statement 2, the fan is on. So we have to write P and Q. P and Q. What will be P and Q? The book is on the table. What we should use? And the fan is on. So wherever they give you two statement by using and we join the statement, it is called as a conjunction. If P is true, Q is true. If P is false, P, Q, P and Q. If P is false, Q is true. What will be the answer? It will be false. Then next one is called disjunction. What does mean by disjunction? So yeah, disjunction. A disjunction is a compound statement formed by connecting two statements by using the word or, such that the disjunction is true if at least one of the compound statement is true. We can just remember for disjunction, if it is F and F, it is F, otherwise it is T. You can just remember if it is F and F, it is F, otherwise it is T. We should remember these conditions, which will help us to draw the truth table for upcoming slides. Okay. So yeah, we write it in the form of statement. It is raining, it is cloudy, or we have to use P or Q. It is rainy or it is cloudy. True it if at least one of them is true. 4 is odd, false. 6 is even, it is true. So whenever it is F and F, it is F, otherwise it is true. The answer P or Q will be true. Or in logic is inclusive, meaning one or both can be true. Only false when both parts are false. It is a hint to remember. When both parts are false, you have to remember the answer is also false for disjunction. So yeah, we will move on with some examples. So here we have the sun. The number 4 is even. The number 5 is odd. So you can write what will be P or Q. The number 4 is even, or the number 5 is the number 5 is odd. So we're using and it is asking you to draw the truth table. So P, Q, P or Q. P or Q. So yeah, what is P? The number 4 is even. Yes, it is true. Then 5 is odd. It is also T. So the answer is also T. Only it will be when it is F and F, it is F. Otherwise, it is T. Okay. Then next one, write the disjunction of the following. So today is Sunday. P or Q. We can write it as today is Sunday. Today is Sunday. It is time to eat a anda. संडे हो या मंडे रोज खाओ अंडे सो राइट इट इज संडे और it is raining. It is raining. So we should not use a capital letter in between the statement. It will be small letter. It is raining. Determine the truth value of 2 plus 2 is 5. Q 3 into 3 is 9. So yeah, we are asking you to find the truth value. So P or Q, that will be 2 plus 2 is 5 or 3 into 3 is 9. So we have to write the evaluate means you have to write the table. Certainly P, Q, P or Q. So P 2 plus 2 is 5, it is false. 3 into 3 is 9, it is T. So T, F, T, it is T. Only when the condition is F, F, it is F in the disjunction. So yeah, moving with the next example, next set of examples. I've given you as many as examples so that you people will understand the concept very clearly and you'll have no confusions or doubt in solving them during exam time. The sky is green. 10 is a prime number. P, the sky is green. Q, 10 is a even a prime number. So yeah, we have to write P or Q. What will be P or Q? The sky is green or 10 is a prime number. So whenever it comes like a V shape, it is or. Whenever you see the symbol V, it is or. Then create a disjunction for these. P, cats can fly. Fish, Q, fish can swim. So what will be P or Q? It will be cats can fly. Cats can fly and fish can swim. Fish can swim. So yeah, this is the disjunction we are and now we are you should use or. So yeah, P or Q means it is or. Cats can fly or fish can swim. Then P is x is equals to 3, x is Q is x is greater than 5. You write P or Q, that will be x equals 3 or x is greater than 5. So determine the truth table is writing the truth table for that. So P, Q, P or Q. If it is x is equals to 3, suppose if I take this through, then x is greater than 5, it is false. Then the answer will be T. Then combine using disjunction. P, the bulb is on. Q, the fan is off. So we can write a P or Q as the bulb is on and the fan is off. Then moving on with the next examples, we have identify whether the given compound statements from this disjunction. It is we have to write the compound statements from the disjunction. What are the compound statements we have? P, it is hot. It is hot. And Q, I will wear a jacket. Then write the disjunction and its negation. You have to write disjunction P or Q. I will pass the exam. I will pass the exam or I will attend the party. And now negate it. It is given and its negation. Negation P implies Q. We should use and not. I will not pass. I will not pass the exam or I will not I will not attend the party. So it will be the negation for the given statement. Next one, evaluate this distinction. 7 is divisible by 3, 8 is greater than 5. 7 is divisible by 3. We have to evaluate. We have to write the table. P and Q. So today P, Q, P or Q, P or Q. 7 is divisible by 3. 7 is not divisible. We cannot divide 7. It is a prime number. Then 8 is greater than 5. Yes, it is true. When it is T, F and T, it is T because only the condition is for or is F and F, it is F. Otherwise, it is all false. Otherwise, it is all true. Then moving on with the next one, we have conditional. What is mean by conditional? Conditional or implication? A conditional statement or implication is a compound statement of the form if P then Q. We'll be using if and then to write the statement. Written as P arrow mark Q. P implies Q, which is false only when P is true and Q is false, and true in all other cases. So the condition for implication is if P is T and Q is F, the answer will be P and T and F will be F. Always for implication, it is T and F. It is always F. And how do we represent? We represent it by arrow mark, single arrow. For example, It rains p q, the ground gets wet. So we have to use the word if and then. If in the beginning of p and then in beginning of q. If it rains, then the ground gets wet. If in the beginning of p and then in the beginning of q. So yeah, 2 is a even number, it is true. 5 is a prime number, it is also true. If both are true, the answer is also true. Only one condition, tf, it is f. Okay. The sun is shining, true. It is night, false. If it is shining, it should be morning. P implies q will be false. T f f, remaining all true. Only one case makes the condition false. If a part is true and then part is false, then it is a T F, it is F. Otherwise, it is all true. So we'll move on with the problems here next. So let PB, it is raining, and Q, the ground gets wet. Just we now we have written if it is raining, if P implies Q, if it is raining, if it is raining, then the ground is wet. Then identify P and Q, write its conditional. So here P and Q you should identify, you should leave if and then. So this will be P. P will be a number, a number, a number is even, a number is even, and Q, it is divisible, it is divisible by 2. Then we have next one. Determine the truth value of. What will be truth value for this? P implies Q. 2 is a prime number, true. 4 is an odd, false. So it is TF, it is T. Only when it is TF, it is F. TF, it is F. Otherwise, it is true. Okay. Whenever it is TF, it is answer is false. Then write the converse of the implication. Converse means P implies Q is given. You should write it as Q implies P will become converse. Q implies P will become converse. So here what will be the converse? It is Monday, then we have class. So we have to write first we have class and then we have to write it is Monday. If we have class, then it is Monday. So we have to reverse the statement what they give is called converse. Then write the implication. X is equals to 3, x square is 9. So what will be the truth table of this? So the truth table will be P, Q, P implies Q. X is 3. Suppose if I take x is 3 true, then x square will be 9. It is also true. The answer P implies Q also is true. Only if it is T and F, the answer is F. Otherwise, it is true. Then write the inverse of the following. What is meant by inverse? Inverse is negation P implies negation Q. So what is P here? P, a figure is a square. What will be negation P? A figure is not a square. So we can write if a figure, if a figure is not a square, not a square, then what is the second statement? It has four sides. Negation of that will be then it has, it doesn't have four sides. It doesn't have four sides. You can change some statement for grammatical corrections. You can just do it in a format where we can write the statement in a correct order. Then identify whether the implication is true or false. So yeah, for seventh one, you should write the table P, Q, P implies Q. So 5 is greater than 3. 5 is greater than 3. Yes, it is true. 10 is less than 2. It is false. So TF, it is F. So the answer will be F. From the conditional statement using P you study, Q you will pass the exam. Form the conditional statement. What will it? P implies Q. P implies Q will be if you study, then you will, then you will pass the exam. Start doing by yourself. Write the questions and try to solve. Don't wait for me to solve it. I want you to find the answer. Identify the truth table. Tell me the truth table, what it would be. What will be the truth table for this? We have P, we have Q, we have P implies Q. 6 is odd, it is false. 9 is divisible by 3, it is true. Whenever it is TF, what will be the answer? Yes, TF, it is T. Yes, correct. It is T because only when it is T and F, the answer is F. Otherwise, for implication, it is true. Write the contrapositive of the statement. What is contrapositive? It will be negation Q implies negation P. First, you will see what is P. This is P and this statement is Q. So first we should use not for both. Okay. Then we should write first Q and then we should write P. So yeah, answer is if here for this. If they can explain concepts. If they, negation means if they cannot explain concepts. If they cannot explain concepts, then a person is a teacher. Then a person is not a teacher. So this is how you write. That is contrapositive negation P implies negation Q. So now next one is biconditional or double implication. What is this biconditional? Biconditional is Biconditional is a compound statement of form P double implication Q, that is double arrow mark, which is true only when P and Q are both true or both false. If they have same values, the answer is T. If they have same values, T and T, F and F, it is true, otherwise it is false. So yeah, the number is divisible by 6. The number is divisible by both the 2 and 3. So here we use if and only if. If and only if will be used to connect the statements. A number is divisible by 6 if and only if it is divisible by both 2 and 3. This is true because divisibility by 6 required the divisibility of both 2 and 3 and vice versa. Then you have P, you will get a reward. Q, you complete all the tasks. Though, so the answer is you will get a reward if and only if you complete all the tasks. This implies both the directions. You get a reward only when you complete all the tasks, and complete all the tasks guarantees a reward. So yeah, moving on with the examples for this, we will just solve. What are the examples? How to solve them? Write a biconditional statement. Write a biconditional statement by using if and only if. So what will be it? P double implication Q. It will be a triangle. A triangle is equivalent, equilateral. Equilateral means all the sides are equal. Equilateral if and only if a triangle, second statement, a triangle has three equal sides. Then what is next one? Express the following biconditional statement symbolically. So how we write? A figure is a square. So P will be a figure. A figure is a square. Then what will be Q? Q will be, it is a rectangle with all sides equal. It is a rectangle. It is a rectangle all with all sides equal. So what will be the symbol for this? P double implication double arrow mark Q. Then determine the truth value of the biconditional statement. So they're asking you to draw the truth table. So yeah, how to write? P Q P double implication Q. So 5 is greater than 2. Yes, it is true. 7 is less than 3. It is false. So here T F, the answer is only if both are same we should be writing to T. If not, if it is F. Then next one is 3 plus 4 is 7. 9 minus 2 is 7. What is the biconditional statement for this? If P double implication Q, if 3 plus 4 is 7, then if it is biconditional. So it is, say 3 plus 4 is 7 if and only if 9 minus 2 equals 7. Now what will be the table for this? The table P Q P implies double implication Q. So yeah, 3 plus 4 is 7, it is T. Then 9 minus 2 is also T. If both the values are same, the answer is T. Moving with the next one, we have next example. Construct the truth table for the biconditional statement. Truth table P Q P double implication Q. So the light is on. Suppose we imagine light is on. The room is bright. Yes, it is bright. If both are same, the answer is T. Then next one, you have P Q P double implication Q. It is saying here if P is true and Q is false. If both are same, it is T. If not, it is F. Write the truth value of the biconditional statement. Then this is then if P double implication Q is true, P is true. What must be the truth value of Q? It is saying P Q P double implication Q. It says yeah. If a double implication P implies Q is 2, true, P is true. What should be Q? Q also should be T only. When both are T, it is T. So it should be true. Then moving with the next question, you have translate the following into a biconditional statement. What is you are eligible to vote? It is actually in biconditional. You should just write a symbol for this. P, you are eligible for vote. Q, you are 18 years or older. Then P implies Q. Is the following a valid biconditional statement? Justify your answer. A number is even, P, uh, it is divisible by 4. If a number is a Q, if the number is even, then it will be divisible by 4. Yes, it is a valid. It is valid statement. So P implies Q. If the number is even, true, should be divisible by 4. Then if both are T, the answer is also T. Write a biconditional statement about the days of week using the statement. Today is Sunday, tomorrow is Monday. What it will be? B double implication Q. Today is Sunday. Today is Sunday. If and only if and only if and only if tomorrow is Monday. Tomorrow is Monday. This is how you'll write the biconditional statement or double implication. So yeah, quick recall for the whatever you have learned here. Negation is nothing but not, and these are the two symbols for negation. We will reverse the truth values of the given statement. Then conjunction. Conjunction means and symbol will be cap. It will be true if both are true. Both the values are t. That is t and t. It will be t. And the next one is disjunction. The symbol is V and we use the word R. Here you can write F and F, it is F. If both are true, false, it is false, otherwise it is true. Then implication. If then. We will be using if then arrow mark, single arrow. False only if P is true and Q is false. If it is T and F, it is F. Then biconditional and if and only if, double arrow mark. True if both are same. If you have TTFF, the answer will be T. Otherwise, it is false. So this will be a small recall to remember. It's very important. You should remember them. Then we'll move on with the converse. What is converse, inverse, and contrapositive? So converse, as I said you, we are reversing the implication statement. If it is P by Q, we should write Q by P is called as converse. If it is P implies Q is given, we have to convert it into Q implies P. For example, it is raining, the ground gets wet. P implies Q will be if it rains, then the ground gets wet. Reverse that. First, you should write it ground and then you should write it is rain. If the ground is wet, then it rains. It's called a converse. It's very simple. You have to just reverse the implication statement. Now, here it is given P implies Q. If a shape is a square, then it has four equal sides. P, the shape is square. Q, the shape has four equal sides. Reverse it. First write Q and then write P. The shape, if the shape has four, if the shape has four equal equal sides, then then a shape, then a shape is a square. Is a square. Will be the answer for converse. If a number is even, then it is divisible by 2. A number is even P, and number is divisible by 2. How do we write? Reverse it. First you write Q and then we write P. So it is if a if a number if a number is divisible by 2, then you should read P. Then write P. Then a number is even. Is it clear? Then, if a student study hard, then they will pass the exam. So, what will be P and what will be Q? You should leave if and you should use then and write P and Q. A student, a student study hard, study hard. Then they will pass the exam. So, what will be reverse of this? Converse, if they will pass the exam, if they will pass the exam, then a student, then a student steady, steady is hard, will be the converse of the given statement. Then next one, if today is Sunday, then tomorrow is Monday. How do we write? P is it, if it is Sunday, then it is Monday. Then how, what will be P implies Q? We will write if tomorrow is Monday, then today is Sunday. If tomorrow is Monday, then today is Sunday. Will be the converse. The polygon is a triangle. The polygon has three sides. What will be converse of this? First, if the polygon is a triangle, if a polygon is a triangle, then it has three sides. So what will write? What will be converse? If the polygon, if the polygon has its three sides, then it is a triangle. It is a triangle. What will be this? P Q, Q implies P. So yeah, P is, it is a polygon. It is a triangle through the polygon has three sides. It is also true. Whenever it is implication only TF, it will be F. Otherwise, the answer will be T. Then the next one, the person is a doctor. The person has a medical degree. So here, what will be P implies Q? If a person is a doctor, if a person is a doctor, then we should then the person has a medical degree. What will be converse? The person, if the person has a medical degree, if the person has medical degree, then the person is a doctor. Is a doctor. What will be the truth table of this? P, Q, P implies Q, or Q implies P, Q implies P. So it is, the person is doctor, yes, he is having a medical degree, true. If both are T, the answer is T. Only the condition here is TF, it is F. Otherwise, it is all true. Then, moving with the next one, we have inverse. What is mean by inverse? Inverse is a condition statement is form of negating both the hypothesis and the conclusion without switching their order. Will, if it is P implies Q, inverse will be negation P implies negation Q. We have to negate the two statements and we have to use if then and join them. So number is even, divisible by 2. We have to use not for both and we should join. If a number is even, then it is not divisible by 2. So what will be negation P implies negation Q? If it is not even, then it is not divisible by 2. We have to use not for both the statement and write the implication statement. Okay, that is called inverse. So yeah, write the negation for write the negation verbal and symbolic. A number is divisible by 3, the number is multiple of 3. So what if the, number if a number is divisible, if a number is divisible by 3, then the number then the number is a multiple of 3, is a multiple of 3. Then what will be inverse of this? You have to use not in both the statement. A number if a number is not divisible by 3, then the number is a is not a multiple of 3, will be the negation P implies negation Q. Then next one, P, you wake up early, you no, Q, you will catch the bus. So you if you wake up early, then you you will catch the bus. We should use negation P, negation Q means we'll be using not. If you do not, if you does not, if you does not or does not wake up, if you does not wake up early, then you will not catch the bus. Then it is raining, the street will be wet. Use if then and symbolically. So P double implication P in negation P implies negation Q will be it is not raining. It is not raining. No, it if it is not raining, if it is not raining, the street, then the streets will not be wet. Then you have identify the correct inverse. As figure is square, it has four equal sides. Which of the following is a inverse for P implies Q? Till negation P implies negation Q. True and false. We have to write true or false for the statement. P Q P negation P implies negation Q. So yeah, P is the person is honest. If you take true, the person is trusted. It is true. For implication, the answer is T and T. It is T. For we'll write one more. We'll just write here P implies Q, and then we'll write negation P implies negation Q. So yeah, it is if both are T, the answer will be T. Then what will be negation of it? It will be false. Then x is a positive number. Root two root x is a real. Then what will be negation? If root x, if root x, if x is if it is if x is if x is a positive, if x is a positive number, then root x is equal real. Now what will be negation P negation Q? This is P implies Q. Then negation P implies negation of Q will be if x is not a positive, if x is not a positive number, then root x is not real. Then what is the table for this? It will be P Q, P implies Q, negation P implies negation Q. So P x is a positive number. Suppose we take it as true. Root x is real. Positive number, root x will be real. It is also true. The answer will be T and the negation will be false. Then moving on with the next one, you have find the blank. Filling the blanks. The device is plugged in. It works. Complete the inverse statement. If the device is unplugged, then it does not work. A number is even, it is divisible by 2. What will be inverse? A number is not even, then it is not divisible by 2. Divisible by 2. So yeah, it will be P negation P implies negation Q. Then write their own or create a own if P then Q statement in a real life. Then write the negation. If there if there is a petrol in a bike, then we can drive it. If there is a petrol in a bike, then we can drive it. So what will be negation? Inverse of that, if we do not have petrol in a bike, then we cannot we cannot derive it. Then write any conditional statement from your textbook or syllabus for inverse, converse, and contrapositive. For I'll take one problem example. Let me take P implies Q. If students if students like maths, then then they will pass. Then what will be your inverse? That will be converse first. Q implies P. If students pass, then the students like maths. Like maths. Then what will be inverse? Negation P implies negation Q. If student do not like maths, then they do not they do not pass. Now what will be negation Q implies negation P, contrapositive. If the student if the student do not pass do not pass, then the students then the students like maths like does not like maths. Okay, moving on with the next slide, we have contrapositive statement. The contrapositive is formed by reversing and negating both the hypothesis and the conclusion. So yeah, what is meant by contrapositive? P implies Q will become negation Q implies negation P. Switch is on, light is on. If P implies Q, if the switch is on, then the light is on. So we have to negate. We have to use not for both, and then we should use first Q, and then we should read second. So here, if the light is off, or if the light is not on, then the switch is not on, and then the switch is not on. Will be the contrapositive of the given statement. Then moving on with the next statement, we have write the contrapositive with a logical symbol. So yeah, it will be negation Q implies negation P. So it will be first you have to do not for both add not and then write first Q and then P. That will be the number first Q. The number is not divisible by 2. Then a number then a number is not even. Then, what is the contrapositive? It is rain, the ground gets wet. So we should use not for both, and first use Q and then we should use P. If the ground, if the ground is not wet, then it is not raining. It is not raining. Then you are eligible to vote. You are at least 18 years old. So we should use not for both, and first use Q and then you should use P. If you are not at least at least 18 years old 18 years old, then you are not eligible to vote. Then the switch is on, the fan is run for the fan runs. So we have to write not for both, and then you should use Q in the beginning. So that will be the fan is not running. If the fan is not running, then the switch is off. The switch is off. Then moving with the next one, we have so yeah, if P implies Q is true, then converse of negation P implies negation Q, always true, false, or depends. So if it is P implies Q is true, then negation P implies negation Q will be false. Then this is negation Q implies negation P is also false. Then If the statement, if the number is divisible by 6 and then it is divisible by 3 is true, what will be contrapositive? P implies Q is true, then negation Q implies negation P will be false. Then form the contrapositive. If the person is honest, then they are trusted. You can write first Q and then P. If they if they are not trusty or not trusted, then a person is not honest. Okay. Then next honest, honest. Then if the traffic light is red, then the car stops. If the car does if the car does not stop, then it is not having then the traffic light is not red. Then the traffic light is not red. Light is not red. Hope you can write now. If the student submits the assignment, then they will get a full marks. So you should write this first. If the student will get full marks, then if the student does not get a good marks, then the students will not submit. Then the students have not submitted the assignment. So it is if the student if the student did not if the student does not get full full marks, then the student had not had not submitted assignment. Then moving with some more questions on contradiction, biconditional, contrapositive. So yeah, moving with the next questions, you have, yeah, multiple choice, identify the contrapositive for the given statement. P implies Q, contrapositionally negation P implies negation Q. Stem symbol to verbal, write it words. So yeah, it is. If it is cold, then I wear a jacket. So yeah, the answer for negation P implies negation Q is this wear, and P is it is cold. You should use not for both. So I I wear if I wear a jacket, then it is not cold. Then P implies Q. If the plant gets sunlight, then it grows. So yeah, actually P negation Q implies negation P only. If plants does not do not do not grow, then it is not getting sunlight. Then moving on with the next one, we have base statements and reference. P implies Q. If a number is divisible by 4, then it is even. Conditional statement will be what? It will be if a number is not even, then a number is not divisible 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 by 4. Take negation Q implies negation P. Then write the converse for the given statement using symbols. Write the converse, direct construction questions. Italy Q implies P. Write the inverse for the statement using symbol. It is negation P implies negation Q. Write the contrapositive for the statement using symbol. Negation Q implies negation P. Then you have next one is filling the blanks. The converse of P implies Q will be Q implies P. The inverse of P implies Q will be negation P implies negation Q. The contrapositive of P implies Q will be negation Q implies negation P. Multiple choice questions. Which of the following is a contrapositive of a number is divisible by 4, then it is even? First you should write q, and then we should write p with the not statement, using not statement. If it is not even, if a number is not even, then it is not divisible by 4. That will be c. What is the inverse of the same statement? Inverse means it is negation. Converse is negation. Here it is contrapositive. Negation q implies negation p. So yeah, inversely negation p implies negation q. So if the number is not divisible by 4, if the number is not divisible by 4, then it is not even. That is a, option a. Then moving with the next one, you have next statement. If the student completes all its homework, then they will pass the exam. We have to write converse, inverse, and contrapositive. So yeah, what is a student completes all homework, student pass the course? This is an important question. They'll give one statement and ask you to write all three. It will come for 3 marks. So yeah, first one is P implies Q. If student complete all homework, then student student passes the course. Then next one, negation P implies negation Q. If student do not complete do not complete all homework, then student will not pass in the course. Then contrapositive will be negation Q implies negation P. If the student does not or do not passes the course, then student had not completed all his homework. So yeah, the next one is P. Q implies P. The number cannot cannot be written in the form of m by n. This is m by n. Then root 2 a is an rational number. Is a rational number. Then you have the number negation. You should write not for both, and write if here if the number if the number if the number 2 if the number root 2 is an irrational, is a is not an irrational. Okay, I'll just correct it 1 second. So yeah, it is if root 2 is not if root 2 is not irrational number, then the number it cannot become can. If it is negated, can be written in the form of m by n. Then next one is negation Q. First you should use Q and then P. If the number can be written, cannot, it will change to can. If the number can be written in the form of m by n, then root 2 is a root 2 is an irrational number. Root 2 is not an irrational number. Then moving on with the next question, we have match the following here. Converse, it is converse is q implies p. Inverse will be negation p implies negation q. Contrapositive will be negation q implies negation p. So next one we have write the statements. Okay, write the statements. Translate the following in verbal language. A square is a quadrilateral. A square has all its sides are equal. So we have to write by seeing the symbol what they've given in the question. So the next one is here we learn how to do the translate the following verbal languages in verbal language, the symbol into verbal language. So here they've given. I'll just read out the answers. You can just write it. P, a square is a quadrilateral. Q, a square has all its sides equal. So what should be negation P and negation Q? And when it is negation means we should use not. And means we should use cap means we should use and. Again negation Q means not Q. So we should use not for both and we have to write. So here the answer will be A square is not quadrilateral and a square has does not have a square does not have all its sides equal. Then what is mean by arrow mark? Arrow mark is to use if. Then we just write if square is a quadrilateral, then a square has all its sides equal. Then all its sides are equal. Then what will be q implies p? It will be first you should read q. If a square has all its sides equal, then a square is a quadrilateral. Then what will be negation pq and negation p? We will just write if a square is not if a square does not have all its sides equal will be negation q. Then a square is not a quadrilateral will be negation p. Then p and negation q. First read p. A square is a quadrilateral and cap means and. Then negate the q value and a square does not have all its sides equal. Then what will be negation p? A square is not a quadrilateral. What will be negation q? A square does not have all its sides equal. Then what will be p and q? A square is a quadrilateral. We should use and. A square is a quadrilateral and a square has all its sides equal. Then what will be or? V or a square is a quadrilateral or a square has all its sides equal. Then P double implication Q means if and only if. A square is a quadrilateral if and only if a square has all its sides equal. Then negation P or negation Q means you should use not for both the statement and join them by using or. That will be a square is not a quadrilateral or a square does not have all its sides equal. Then P or negation Q. P is a square is a quadrilateral. V is or a square is a quadrilateral or negation Q. A square does not have all its sides equal. Then negation Q will be a square does not have all its sides equal if the square it is if then if the square does not have all its sides equal, then a square is a quadrilateral. Then negation p implies q will be negation p. If a square does not is not a quadrilateral, if a square is not a quadrilateral, then a square has all its sides equal. So this is how you will convert symbol into verbal language. So the next one you have next example you have hard work and success. Negation p not hard work, or you can say no hard work no success. No hard work and no success. I know my handwriting is not coming proper because it's a smart board and you need to adjust with my handwriting. You just understand my concept of teaching what I'm teaching, trying to explain you. Handwriting doesn't matter here. Okay, so I'll try to write little more understandable for you. Negation P will be no hard work. Cap is and. Negation Q will be no success. No hard work, no success. Then P implies Q if hard work. You should use if then, if hard work, then success. Then Q implies P, reverse them if success, then hard work. Then negation PQ implies negation P if P, if no hard success, if no success, then no hard work. Then no hard work. Then P and Q, negation Q, hard work and no success. Then negation P, no hard work. Then negation Q, no success. P and Q, hard work and success. And success. P or Q, hard work or success. P implies Q, hard work, if and only if success. Negation P or negation Q, no hard work, no hard work, and no hard work or no success. P or negation Q, hard work or no success. Negation Q, no success, if no success, then hard work. Negation P, if no hard work, then Q, success. So here we are going to continue with the problems. Example 1 statement. We are going to convert the statement in the symbol, that is symbolically we are going to represent the given statement. So how we are going to do? Here, if it rains, then the ground will be wet. If and then is used for implication. So to represent implication, we use arrow mark. Here P is it rains and Q is the ground will be wet. So we can represent that as P implies Q. What will be the negation of P implies Q? The negation of P implies Q is logical equivalent to P and negation Q. So here P and negation Q is P is it rains but the ground is not wet. It is a negation is it rains but ground is not wet will be the negation for the given statement. Then moving on with the next one, we have example 2 statement all students are present. So here P is all students are present, and negation of this will be not all students are present, or also we can write some students are absent for negation of the given statement. Then John is tall or Mary is short, or is represented for V, that is V symbol, that is disjunction. So here P will be John is tall, John is tall, and Mary is short. Mary is short. So yeah, it is P or Q. That P or Q. So what is the negation of negation P or Q? It is logically equivalent to negation P and negation Q. So here this is called as De Morgan law. It is also called as De Morgan's law. So yeah, negation P or Q will be logical equivalent to negation P and negation Q, where it says John is not tall and Mary is not short. And then negation P and Q is logical equivalent to negation P or negation Q. That is, John is not tall or Mary is not short will be the answer for the given question. So yeah, moving with the next question, we have let P and Q be two primitive statements such that P implies Q is false. Determine the truth value of the following. So here what will be the truth value of the following? Here given P implies Q is false. This is possible only when P is true and Q is true. There the condition is for if P implies Q will be false only when it is P is T and F is false. So yeah, we will just check for the condition P and Q. P is true and Q is false, then it is 1 or 0, that is false. T and F is false. Then second one, if you take negation P will be false or false. For F and F is this false, then it is P or P implies Q, that is false implies true, that will be true. Then true implies false will be false. So yeah, the answer is P implies Q will be false only when the condition is if both the values are true and false, it is the answer is false. So here we can see where it is true or false. It is there in the first one and it is in the third one, fourth one. So the answer is 1 and 4. So moving on with the next one, we have find the possible values of P, Q, and R if we have P implies Q or R is false. So, if P is true, if you take P is true, Q or R is false. If P is true and Q or R is false, then we can take Q or R. Q will be false, R will be false. If it is false and false, the answer is false. So, Q or R is false means Q is false and R is false. Therefore, the answer are false. Therefore, Q and R are false and P is true. P is true and Q and R are false. Then it is P and Q implies R is true. When is the condition P and Q implies R is true? P is true and Q implies R is also true. If we are as they are saying, yeah, to prove that P and Q implies R is Q implies R, then P and Q implies R is true. Then when it is a condition, yeah, if P is true and this value is also true, it is T and T, the answer will be T. Therefore, P value should be true and Q implies R also should be true. Then only we get P and Q implies R true. So yeah, P will be true and this is also true. If Q implies R will be true, when is the condition Q implies R is true? If it is TF, it is F, otherwise it is all true. So we should not check for this condition, but otherwise it is all true. So Q implies R is true if Q and R are false and Q is false and R is true or Q and R is true. So you have many conditions like Q can be false and R can be true, then Q can be true and R can be false, then both can be TT, then we will get answers as T. So these are the three conditions in which the value will be true. It's been given. Then moving on with the next question you have. Construct the truth table for the following compound preposition. So how to construct the truth table? So yeah, we have three components. So three components will be 2 to the power of 3 prepositions. So it will be 2 power 3 will be 8. So we need to draw 8 columns plus 1. 8 plus 1. 1 for the heading. So total we will be drawing 9 rows. So yeah, whenever three compounds are there, we will be drawing 9 rows. Now how to write the heading? So here we have first P, Q and R. First is P, Q and R. So we'll be taking P, Q and R. Then what is in the bracket? First you will take in the bracket P or R, Q. Then we'll take the whole. That is P or Q and R. Then this side we'll take the bracket first and then you will take the whole in the next column. So now let me solve this. If it is three component, how do we write the truth table? It's very simple. Since it is 8 rows, we will write 4 times T and 4 times F. Then we'll write 2 times T and 2 times F. 2 times T and 2 times F. Then we'll write 1 time T and 1 time F. So it will be 4, 4, 2, 2, 1, 1. So this is the way how you will write the values. Now we will simplify here. It is or. What is the condition for or? Or says it is f and f. The answer is f. So we will check in p and q column. We have f and f. So let me check here. It is f and f. Do we have? So yeah, we don't have f and f, f and f, f and f, f and f. So we have in the last column and then this. So here this is f and f. The remaining all is t. The remaining all is t. T, 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 T. Then we'll check for the next one. It is P or Q. Means we'll be checking for this column, fourth column, and R. We'll be checking for R. So what is the condition? It is and. What is the condition for and? It is T and T, which is T. For third and fourth, we will be checking this condition, T and T. We'll check here. What is here? Do we have T and T in this two? No. Yeah, we have here T and T. It is T. Then yeah, T and T. It is T. Then we don't have. Otherwise, also everyone is false. Everyone is false. Then Q and R. Now we have to check for Q and R. Q and R. So here it is for Q and R. We'll check for this too. Q and R. Condition is and. And means again it is T and T. We have to check for T and T. So first one we have is T and T. Then we have here this line is T and T. Then the remaining all are false. The remaining values are false. So yeah, it will be F, 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 and F. Now the last one is and P or Q and R. So we now the last one is we'll be checking for P, that is this first line, and Q and R will be the line which we did in the last. So we will check in this too. Condition for this both is or. Or means F and F is F. We will check for F and F. First one, second, third, fourth, fifth, sixth. Sixth one, F and F is F. Then seventh is also F and F is F. Then eighth one is also F and F is F. So three conditions are there. The remaining all the values are T. So this is the way how you construct the truth table. Hope you people have followed. We'll move on with the next question. We have tautology. What is mean by tautology? Tautology is a logical statement that cannot be false under any possible true value combinations. It is universal and unconditionally true. It means that it contains only one or t in the final column of the truth table. So if the final answer is all t, then it is called tautology. So let us prove this condition. Let us prove the draw the table for this what they've given. So here we have first we have only two columns, only two components. So certainly 2 square will be 4, then 4 plus 1 we have to draw 5 rows, 5 rows, 1 2 3 4 5. Then we will write this p and q. So it is p and q. Then we'll go for the first bracket. It is p implies q. Then you'll go for second bracket. In second bracket we have negation p. First we'll write negation p. Then along with negation p, we have q. Negation p implies q. Then we have to join this both. So it will be p implies q or negation p implies q will be the heading of the table. Now we will solve this. If it is four components, how we are going to write? We are going to write it as TTFF, half, TTFF, TF. Now condition on finding the condition for that, we have that is arrow mark implication. Condition is TF, it is F. Condition for implication is TF, it is F. Otherwise it is all true. Then what will be negation p? whatever we have in the p, we will reverse it. Tt means ff means tt. Then we have to see negation p implies negation q. First we will see the values of p, and then we'll see the value of q. That is tf. We have to check for t and f. So let me check. So we have here f t. Wrong. No, we cannot. F t. Ff. No. T t. No. Then you have t and f. Yes, we have t and f. It is f. You have to check for t and f. First negation p and then q. T and f is f. Remaining all is t. Now the final one is you have to check now. Check the columns for P implies Q will be this column, P implies Q will be this column, and negation P implies negation Q will be this column. Now we have to check the condition is or. So if the condition is or, what is the here? What will be that? That will be F and F, it should be F. Otherwise it is true. We'll just see F and F. No, we don't have. It is F and F. No. Again it is F and F. No. If it is F and F. No. If it is there is no F and F for or, then the remaining all will be T. Remaining all will be T. Therefore, the given preposition, that is, yeah, it is tautology. The given it is tautology, because all the values in the final column is true. The answer is tautology. So yeah, 2 to the power of 2 will be 4. So what is mean by tautology? Tautology is nothing but all the given values in the last column should be true. Then it is called as tautology. Now we'll do the next one. Yeah. So yeah, what will be the next one? You have it is here 2 to the power of 2 is 4. So here we'll be writing 4 rows and 1 extra. Then now we have only 2 p q. Then we'll go for the first bracket. P implies q. Then we'll go for the second bracket. We have negation q and then negation p. Then we'll take all together negation p. Negation q implies negation p. And then we'll take the whole thing. P implies q, double implication, negation q implies negation p. Now we'll start solving this. So we have tt ff, then tf tf. Now implication is, if it is t and f, the answer is f. Otherwise the remaining is all true. Then negation of p with q will be tf tf. It will become ft ft. Then negation of p will be ttff, so it will become fftt. Reverse. Whatever is there, we'll reverse them. Then now you have to check the condition implication for negation q and negation. These two columns. What we should check? TFF. We have to check for T and FF. So we have T and F in the second one. So it is F. Otherwise it is all true. Now we have finished finding all the, and now we are going to join them. The answers what we got, we'll just check final answer for this. So yeah, what we have is, now we'll be checking for P implies Q and negation Q implies negation P. So yeah, we should check for double implication. What means double implication? If both are same, the answer is T. If it is T and T, T. F and F is also T. We'll just check for that. It is T and T, it is T. F and F, it is T. T and T, it is T. T and T, it is T. So all the values are T. Therefore, it is a tautology. Then moving on with the next question, we have next question is, either the statement is true or it is not. Why? Which is always true? Just let me check now how to do this. Yeah, P negation will be F and T. Then or P or negation Q. Or means it is, what is the condition for or? It is FF. It is F. Otherwise it is true. So here there is no ff, so the answer will be true. Since the result is always true, it is a tautology. Since we got both as t, it is a tautology. Here it will be 2 to the power of 1. We have only one compound statement, so we'll have only 1, that is 2 rows and plus 1 for the heading. It will be 3 rows. Then moving on with the next question for tautology, We have all the questions on tautology. Now let me solve by using the statement. Let the preposition be P, it is raining, Q, the ground is wet, and R, I will carry an umbrella. So now the preposition given is P and Q, then implies P or Q. So we have to find whether the given preposition is a tautology or not. So here, how do we prove? We can prove by using the table also. We have P, Q, and R. So it will be T, 4, and then F, and F4. Then we will write T, F, 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 F. Then we'll write TF, 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 TF. Now we have P and Q. P and Q. So that means we have to check in first and second column the values for them. So let me check. Condition for and is T and T, it should be T. T and T, it is T. Then again second is also T and T, it is T. Then third, fourth, fifth, sixth, seven, eight. We don't have anywhere. So we'll write it as false. Then the next one is P or R. So or we have to check the condition now for or. So it is or is F and F, it is F. We have to check in the first and third one. We have to check in the first column and third column. We have to check for FF. So we don't have F and F. We don't have here F and F, F and F, F and F, F and F. Here we have F and F. So that is first we don't have F and F. T, 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 T. Then it is F and F, it is F. Then again it is T, then F and F. We have F and F here and in this. So we'll write F remaining all T. Now the last condition is, it is asking for P and R implies P or R. We have to check in this too. Condition is arrow mark, that is implication, means TF, it is F. We have to check for the condition TF. TF, no, 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 no. Only in that condition it is false. Otherwise it is true. Otherwise it is true. So all the values is true. T. Therefore, since every answer in the last column is true, it is a tautology. So, in simple word, we can say that it is a tautology because P and Q is true. P or R must also be true as well, since P is already true. If value of P is question number 2, let the switch is on P, Q, the light is on, R, the fan is working. So let us check for the conditions what they have given. It is P, Q. If it is P, T and T, F and F, and Q will be T, F, T, F. Now it is P or Q. Condition for R is if both are false, the answer is false. The remaining all is T. Then it is negation P. Negation means whatever values of P is there, we will reverse it. F, F, T, T. Then negation Q will be whatever we have written for Q, will negate it. That is F, T, F, T. Now we will write negation P and negation Q. Negation P and negation Q is nothing but for these two values we have to check for the condition and is T and T, it is T. So we have here T and T, it is T. Otherwise all the values are false. Now the final value is this, we'll call it as 1 and 2. So we'll write 1 or 2. 1 or 2. What is the or condition? For this both we have or. So the condition we have to check for or, that is for 1 and 2. So this, and for this column we will check or, that is F and F, it is F. We'll just check F and F. No, we don't have F and F. No, here we don't have F and F, and even for this we don't have F and F. So if it is not F and F, then all the values will be T. Since all the values are T, it is called as tautology. Now it means either at least one of them is true or both are false. It always results in the true, hence it is a tautology. Is proved. Now moving on with the next question, we have tautology with one prepositions. So here how to prove this is a tautology. So here T will become F, negation F will become T. Now we have to find or for this too. What is condition for or? Or is F and F, it is F. We'll just check. Do we have F and F? No. We have F and F? No. That means both the values are T, therefore it is a tautology. Then moving on with the next question, we have preposition, a tautology of two preposition, that is P and Q. If it is P and Q, it will be T, T, F, F, T, F, T, F. So here and is nothing but if both the values are T, the value is T, otherwise it is false. Otherwise it is false. Now we will check for P and Q implies P. P and Q implies P. So we'll be checking for this table and this table, but we have to go in a reverse order because here we have P and Q in the beginning. So we'll check like this: T and T, it is T. F and T it is T, F and F it is T, F and F it is T. Only for the condition, for implication it is T, F it is T, but we don't have that value. Therefore, all the values are T. Therefore, it is a tautology. Then moving on with the next one, we have for three prepositions P, Q, and R. How do we write this P, Q, and R? We can write this as T, 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 T four times, and then F four times. F, 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 F. Then T, T, F, F. Then T, T, F, F. Then we'll write T, F, T, F, T, F, T, F. Now here we have P implies Q. Implies is T, F, it is F. T and F, it is F. We'll just check for P and Q first two lines. So we get what are the values we have. Just check out. So we have here T, F we need. We have T, F. It is in the third place. T, F, it is F. Then fourth is also T, F, it is F. Then we don't have. The remaining will be, the remaining values will be T. The remaining values will be T. Now next one is Q and R. So this in this two we'll check the same condition once again. We'll check it for uh, T and F. It is F for the second and third. Yes, we have here T and F. It is F. Then we have here T and F. It is F. Then we don't have. So the remaining values will be T. So the remaining values is T. The remaining values are T. Now we will check for condition. We have next one is uh, P implies Q, Q implies P. That is this two table columns. We have to check for and. And is nothing but if both are T, the value is T. If T plus T, it gives you T. So here we'll check T and T. Yes, it is T. No, we don't have. Here we have T and T. It is T. Then no. Here we have T and T. It is T. Yes. Then T and T. It is T. Otherwise, it is false. Now, then you have P implies R. Now we have to check for P and R. P and R. So that is first one and third one. We have to check for the condition implies. Implies means what? It is T, F. It is F. So it is T and F. It is F. Then we have here T and F. It is F. Then we don't have other place. So the remaining all will be T. Now we have this. The final answer will be. The final answer will be. We have to check in this two. The condition is implies. Implies means it is T plus F will give you F. So yeah, we'll just check T and F. No, 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 no. If there is no T and F, the values will be T. Therefore, since all the values in the last column is T, it is called as tautology. Now, moving with the next question, you have is this a tautology? We'll just check is it a tautology? P Q, then P and Q, then P and Q implies P. Now Italy, we'll just find the value for this. So we have here T T F F T F T F. So now P and Q, T and T, it is T. Otherwise, it is false. Then we have to check with this with first column. We have to check for implication. Implication means T plus F will give you F. We have to check for this condition. So yeah, we will check T and F no. T and F no. T and F no. T and F no. If there is no, the remaining all will be T. And if it all the values are T, it is a tautology. Then moving with the next one, we have I've done a lot of questions for you so that your confusion on this tautology, contradiction, and contingency will get cleared. So let us do this now. First, we'll have P and Q, then first bracket, P implies Q, then second bracket, Q implies P, and then you should write the whole thing P implies Q or Q implies P. Now, let me take T T F F, then it is T F T F. Now, implies is nothing but whenever it is T and F, the answer is F, otherwise, remaining is T. Then Q implies P means you have to see reverse. We have T and F. Yes, we have here T and F. Then it is F. The remaining all will be T. Now, for this two columns, we have to check for this. And for this, we have to check for condition or. Or is F and F will give you F. So, we'll just check whether we have F in both the sides. No, we don't have anywhere. Then the answer is T. Therefore, it is all the values are true. Therefore, it is a tautology. Then with the next question you have, next question is Determine if the preposition is always true. Now next one you have is P Q, first bracket P implies Q, then negation P and then negation Q, then you'll write the second bracket negation P and negation Q. Now let me call this as 1 and let me call this as 2. Shortcut, I'll just write 1 or 2. 1 or 2. So now let me, if I have solved this, T and T, F and F. So delete T and F, T and F. Or is nothing but T and F, it is F. The remaining all it is T. So negation of P will be F F T T. The negation of Q will be F T F T. Then what will be this both and will be T plus T, it is T. So we have T plus T. Yes, we have in the last T plus T is T. Remaining all is false. Then now finally we have to check for the values of this first one and this second one. So the condition is or is F and F will be F. Just check whether we have F and F. Yes, we have here T and T, T and F, F and F is F, then T and F, no, then T and T, no, it is T, T and T. Since the values are not T, it is not a tautology. It is last column is not true, it is not a tautology, not a tautology. For not a tautology. So here they have given P. First one is P double implication Q. So we have P and Q. So first bracket is P double implication Q. The second bracket we have is negation Q. So we'll write negation Q. And then it is P double implication negation Q. So now we'll call this as 1 and we'll call this as 2. Then we have 1 and 2 with the OR operation. So we'll do 1 or 2. So now how to simplify this? We are going to find it is T and T, F and F. Then it is TF, TF, TF. Then double implication means if both are T, same, the answer is T. If both are F, the answer is T. Otherwise, it is false. Then you have negation Q. Whatever we have Q, we'll negate it. That is T means F. If it is F, it is T. It is F. T, it is F. And F, it is T. Now we will find the double implication for the first P and for negation Q. So now it is double implication again. The both values should be same. We don't have. So here it is same. T and T it is T. Then F and F it is T. Then the remaining is false. Now what we need to do is we need to check the first and second condition. So the first and second condition here is one is this one and the other one is this. So we'll check in this or condition. Or is F plus F is F. So we'll just check for this condition. If it is F and F, it is F. Remaining all it is true. So we have F and F. No. We have here F and F. No. Here we have no. We have here no. It is all. We don't have the condition F and F. So the remaining all the values will be T. If all the values are true in the last column, then it is called as tautology. So the given preposition is a tautology. Moving on with the next question, we have verify the following compound preposition. So yeah, they have given P, Q, and R. So the first bracket here is P implies Q. Then the second bracket here is Q implies P. Q implies R. Then both of them are connected with OR. So I'll call this as 1, I'll call this as 2, and I'll write 1 and 2. Then we will write a third bracket. What is third bracket? We have P or R. Now we have to write, let me call this as S. Now let me call this as S. Now we have to see S, that is this whole thing. I'll call this as S and it is P implies R. So we'll check in the last two. So that will be 5 S the implication P implies R. Now let us prove this. What is the condition? And now we are going to draw the truth table for this. So here we have it is 4 times T, 4 times F. It is 3 compound statements. It will be 4 times T, 4 times F. Then 2 times T and 2 times F. It will be 2 times T and 2 times F. Then it is T F T F T F T F and T F. Then it is P implies Q. So first and second column, you just check the condition. Implies, that means TF. So here we have T and F. It is F. Then here also we have T and F. It is F. Then we don't have anywhere. So it is remaining all is T. Remaining all is T for implication. Then Q implies R. Means we have to check in the second and third column. For implication, again it is T and F, it is F. Let me check for T and F. Yes, we have here T and F, it is F. Then we have this is T and F, we have F. The remaining all is T. So yeah, now we have to check for these two columns. Condition is and is T and T, it is T. So let me check T and T, it is T. So we have here T and T, it is T. Then we have in the last two T and T, it is T. T and T, it is T. The remaining all will be false. And is nothing but if both are true, the answer is true. Now we will check for P or R. That is second, first one and second one. P, first one and third one. Third column. We'll be checking in first and third column. So what's the condition we have? Next one. Next condition is we are having, that is implication. Implication is T and F. So we'll just check for T and F. Yes, we have here T and F. That is second one is F. Then third, fourth. We have fourth one T and F. It is F. Then we don't have. So the remaining will be true. Now the last one is S. So next one we'll be checking the condition for S and P implies R. So now we are checking again. It is an implication. It is T and F. It is F. We'll just check if it is T and F, 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 T and F. We don't have this condition. So if it is not F, then it will be T for all. So since all the values are T, it is a tautology. So hence it is a tautology. All the values in the last column is true. Therefore, it is a tautology. Now let us check with the next one. We have check whether the statement is a tautology. Again, here we have P, Q, R, then P or R, P R Q, first bracket, then all together P or R or R. Now we know that if it is three components, we have T T, T T, F F, F F, T F, T T, F F, T T, F F, T T, F F, then T F, T F, T F, T F. Now it is or is nothing but F and F, it is F. We have to check if it is in this both. We have F and F. Yes, we have last is 2 is F and F, it is F. Remaining all will be T. So remaining all is T. Now we have to check for the second condition. So we'll be finding it for this P or Q, and we'll check for R, this column. So the condition is or is nothing but F and F, it is F. F plus F is F. So we'll just check if it's there F and F. No, we don't have F and F, F and F. We don't have it. So yeah. So here we have F and F is here. So it is F. Remaining all is T. So here we have F and F. It will be F. Remaining all are T. So since it is a mixture of both, it is not a tautology. If it is both the true and false, then it is called as contingency. If it is a solution, the last line, if it is mixture of T and F, it is called as contingency. So here T and then F, then T and then F, then TF, 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 TF. That is or is a condition where you have P and Q. We have to check for or is nothing but F and F. So we have here F and F. F and F, it is F. Then again you have F and F, it is F. Then we have to check for these two conditions. We should find for or again F and F, it is F. We are just checking it F and F. F we have in the last line, so it is F, and remaining all are true. Therefore, it is not a tautology. If it is not a tautology, then it is a contingency. If it is a mixture of true and false, it is called as contingency. Now, moving on with the next question, we have check whether the statement we have next one is construct a truth table and verify. So we have to write first P Q, R. Then it is negation, P and Q and R. Then it is, I'll write this as M, and then I'll write it as negation M, because I should write the whole thing. Then negation P, negation Q, negation R, negation R. Then it is, I'll write this as negation P or negation Q or negation R. Then I'll call this as N. Now for M and N, we have double implications. I'll write M double implication N. Now let us solve this. So here by solving we get, so here it is T T T T T F F F F. So now it is here T T F F T T F F. Then T F T F T F T F. Now we have P and Q and R. And is nothing but if it is T and T, it is T. So we'll just see in all the three values are T in the given preposition. We'll just check all the T, 1, 2, T is it is true. Then we have no, only one, it is T and T and T, it is T. Others are all, it is false. So yeah, negation of this will be reverse. First one will be false and the remaining all will be T. Then we have to write the negation of P, Q and R. So the negation P, Q and R will be, P will be F, 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 T, 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 T. Then Q will be F, F, T, T, F, F, T, T. Then R will be F, T, F, T, F, T, F, T. Now we have to write the OR for the condition. What is mean by OR? OR is nothing but if both are false, the answer is false. Now we'll just check for that. If both are false for this, if all the three are false, yes, we have here F false, false, false. It is false. Then we don't have anywhere false, so the remaining is. Then we have next one is we have to find in M and R, M and N, double implication. If both are T, if both are T, F, F, if both are same, the answer is T. Here the both is not same, so it is F. The both is not same, it is F, 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 F. If both are same, it is T. We don't have anywhere both for F, for M and N column. They are both different. So the values is F. If it is all the values are F, always true. If it is not true, then it is contradiction. Contradiction. If all the values are false, then it is called as contradiction. If the truth table all the values are false, it is called as contradiction. So yeah, moving on with the next one, we have, is the following a tautology? We have to check whether it is a tautology. Let me check. So it is here. First column, first one is we have PQR, PQR. First bracket is P implies Q. Second bracket is P implies R. Then it is P implies Q, P implies Q, and then P implies Q and R. Then no, before this we have one more. I'll just here we have other one. We have here. So here we have this we have to write. We'll write it as 1 and 2. I'll write this as 1 and 2. Then it is next bracket is P implies Q, P implies Q, and then it is P implies Q and R. P implies Q and R. Then we can write this as 1. So this I'll write it as M, and this a whole term I'll write it as N. So here next one will be uh, M and M implication N. So this is not required, this line. So here we have now we'll just write the values. We have it is T T T T F F F F T T F F T T F F. Then it is T F T F T F T F. So yeah, implication for P and Q, first two lines we have is it is implication is TF. We have T and F, it is F. Then T and F, it is F. Then we have nowhere, so the answer is remaining is T. Then we have P or P implies R. So we have to check in first and third. The condition is same. Again, it is implication. So we'll check it for T and F. We have T and F. It is F. Then we have here T and F. It is F. Then the others all are T. So now one and two. You have to check in this two. And is T and T? It is T. Yes, first one is T and T. Then no. Then no. Then yeah, it is T and T. This is T and T. T and T. T and T. The remaining is false. Now, P implies Q. We have to check for P implies Q. It's already done here. So let me write the same value. TT, FF, TT, TT. So yeah, T. Now we have to find and with R. So we will be checking for this line. So here we will be checking for this one. P implies Q and R. R is the third one. Third column. We'll check in these two columns. The condition is and. And is both should be T. So we have first one is T and T, it is T. The remaining second, third, fourth, fifth one is T and T, T. Then seventh is T and T, it is T. The remaining is false. Now, final answer. We have to check for M and N. So this is M line, and what I found is your N line. Now we'll check for this two, this and this. So it is implication. T and F, it is F. T and F. No, 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 no. T and F, it is F. Then T and F, it is F. The remaining all is T. So yeah, we can find that the given value in the end, the given value what we got is not a T. Therefore, it is the column always is through. No, it is not through. Not no no. It is not a tautology. It is not a tautology. If it is not a tautology, then what is it? If it is not a tautology and if it is a mixture, then it is called contingency. It is called contingency. Moving with the next
Check
question, we
whether this
have
preposition is always true. So let us check whether that is true. So we have here P, Q, and R. So we have three preposition P, Q, and R. So here we will take the bracket which is inside. So it will be Q or R. Then we'll take the whole thing together. That will be P and Q or R. Then we'll take the second side, that is P and Q. And then we have second bracket is P or Q, P and R. Then we will take them together. That will be P and Q or P and R. Then we'll call this as 1 and I'll call this as 2. And then we have in between 1 and 2, we have to check for double implication condition. So it is for 1 and 2. Now let us solve this. Here we have three components. So how do we write through table for that? It will be T, 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 F, 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 F. So it will be T, F, T, F, T. Oh, 1 second. It is not T T. It is T T F F. So we'll be writing here. It will be TTFF. So here we have this is TTFF. So we can write here as that is TTFF, 2 times TT and 2 times F, TTFF. Then it is 1 time T and 1 time F, TF, TF. It is TF and TF. Now we have condition Q or R. What is the condition for R? It is F and F. We get it as F. So let us check if it for Q and R for second and third column. We'll check for the condition what is given. So we will just check. We have F and F in this two. Yeah, we have here F and F. So it will be F. Then we have in the last one F and F. It is F. Then the remaining all is true. The remaining all the components are true. So yeah, the remaining is sorry. It is true. It is T. So it is will be T, 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 and T. Now we'll check for this next one. We'll check from the first column P and this fourth column. So we'll be checking in this two column. First and fourth column, we have to check for the and condition. And is nothing but T and T, it gives us T. So we have to check whether it is T and T. So we have to check for that. We'll just check it. In the first and fourth one, yes, we have one T and T, it is T. Then again, second is also T and T, it is T. third is also T and T, it is T. Then fourth, fifth, sixth, seven, eight, we don't have. So if the remaining will be what, it will be false. So the remaining will be false. F, 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 F. Now P and Q. So first two lines we have to check for and again. So what is and? And is here T and T, it is T. We'll check in the first and second one, T and T. Yes, first one is T and T, it is T and T. Then second is also T and T, it is T. Then third, fourth, fifth, sixth, seven, eight, we don't have. So it will be, remaining will be F. Then P and R. P and R. We will check in for P and R. That is first and third one. And it is again T and T plus T is T. So we'll just check T and T. The first one is T and T, it is T. Second one, no. Third one, it is T and T, it is T. Then fifth, no. Then we don't have. The remaining all will be false. So yeah, the remaining is false. Now we have to check for these two columns. We have P and Q or P and R. So or condition we have to check. Or means it is F plus F is F. We have to check F and F is F. We'll just check it for the next one. It is F and F. So we don't have F and F. Yeah, we have here F and F. It is F. Then here also we have F and F. It is F. Then F and F. It is F. F and F. It is F. F and F. It is F. The remaining will be T. Now this final answer, we have to check for the final answer. Now what we have to check final answer, here we have to check it for one, that is this column, and we have to check for this column. These two columns we are going to check. Condition is implication. Implication means if both are same, the answer is T. So T and T, it is T. T and T, it is T. If both are same, T and T, it is T. F and F, it is T. Then F and F, it is T. F and F, it is T. F and F, it is T. And F and F, it is T. So all the values in the last column is T. Therefore it is a true. Therefore it is called as tautology. Hope you people have understood what is mean by tautology. Practice these problems for doing this part tautology. Now we'll move on with the contradiction. What is mean by contradiction? A contradiction is a compound logical statement that is always false, no matter what is the truth value of its component prepositions are. In other words, a contradiction never be true under any possible scenario. For example, a statement and its negation cannot both be true at the same time. True table output always false. So if all the columns in the last line, all the values in the last column, if it is false, then it is called as contradiction. Now let us prove some problems for this. So here we have P negation P, and then it is P and negation P. So if P is T, if P negation P will be F. If P is F, negation P will be T. Now we have to check for the condition and. And is nothing but T and T, it will give you T. So here we don't have any value which is same, therefore it is false. So here, since the values are false, it is a contradiction. It is a contradiction. So yeah, next one we have it is P and negation P. Then we have P double implication negation P. So it is T, it will be false. If it is false, it will be T. So here double implication is both the values are same, the answer is T. Otherwise it is false. Here their values are not same, therefore the values are false. In both the conditions we have got the values in the last column is false, then it is a contradiction. Okay, so we'll move on with the next two problems where we discuss about the contradiction. So yeah, let me check whether the following preposition is tautology or a contradiction. So let me take it here. First bracket we have P and Q, then P and Q. Then second bracket it is negation P and Q. Then we can call this as 1, we can call this as 2. Then 1 and 2. We have to find for and. So now let me take your values as what are the values for this? It will be TTFF, TTFF, it will be TFTF. Now, and is what? T and T, it is T. T and T, it is T. So we'll just check. It is, yeah, first one is T and T, T. The remaining all are false. Then negation of this table will, this column will be, if it is T, it is F. If it is F, it is T. Now we will check for and. What is and? And says if both are T, the value will be T. So here we'll just check. We have T, no, we don't have. We have T and T, no. We have T and T, no. We have T and T, no. So all these values are false. Therefore, it is a contradiction. Contradiction. Yes. Then next problem we have again. The next one we have is if the following preposition is the following preposition a contradiction or not, we have to check. So it is P and Q. P implies Q. Then second bracket we have negation Q first, negation Q, and then P and negation Q. Then you call this as 1, you call this as 2. Then we'll call 1 and 2. we can write like this. So now the values are, we are just check the values what we get the answer for this. So here we have TTFF, and then it is TFTF. Now it is a single implication. Implication means if it is T and F, it is F. Implication condition is if it is T and F, it is F. So we'll just check where we have T and F. Yeah, we have here T and F, it is F. The remaining will be T. Now negation Q will be, if it is T, it will be F. If it is F, it will be T. If it is T, it will be F. If it is F, it will be T. Now we have to check for P and negation Q. For first and fourth column, we have to check for and. And is T plus T. That is T and T will give you T. We'll just check. We have T and T, no. We have T and T, yes, we have T. Then we have T and T, no. We have T and T, no. So only one. The remaining will be F. Now we have to check. Now condition for this will be, you will be checking for first one and the second one. So the condition is for and is again T and T, it is T. We'll just check. If it is T and T, no. If it is T and T, no. We have T and T, no. We have T and T, no. So where we don't have any T and T, we don't have any TNT. If it is not there, it is all false. So TNT we don't have, so the answer is false. If all the values are false, then it is called as contradiction. It is called as contradiction. Now moving on to the next question, we have, what is your the next, solve this one. Is the following preposition a contradiction? Yeah, we'll just check out. It is P negation P, P negation P, P double implication negation P. So yeah, T F F T. For double implication, if both are same, T T it is T, F F it is T. But we don't have here, so the both values are false. Hence, it is a contradiction. It is a contradiction. Then moving on with the next question, we have, the next one we have is the following preposition is a tautology? We'll just check whether it is a tautology or it is a contradiction. Where we have, I think this we have done, and the previous one it is already done. No, we have, yeah, yes, we have done it this. So I'll skip this because we have already done the same problem. So let me take the next one. We'll check here. Is the following preposition a tautology? We'll just check. Is it a tautology? Here we have P, Q. P implies Q is the first bracket. Then negation P will be here, and then this together. P implies Q and negation Q, and then we'll call this as one, then one and P, one and P. Now what we are going to do, this the we will check whether it is a tautology or contradiction. So yeah, it is T T F F, so it will be T F T F. So now condition for implication is, if it is T and F, it is F, otherwise all the values are T. Then negation Q will be F T F T. Then you have to check for the second, third one and fourth one. What is and is T and T, it is T. T and T, it is T. We'll just check if we have T and T. Yeah, we have here T and T, it is T, otherwise it is all false. Now we'll check it for first one, that is this value, and P value, and the first column. We have to check for and is T and T, it is T. We'll just check whether we have T and T, no. 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 If we don't have T and T, it is all false. So this is not a tautology, it is contradiction, because all the values are false. It is not tautology, it is a contradiction. So yeah, moving with the next one, we have, what is a contingency? Now when all the values are true, it is called tautology. In the last column, if all the values are false, it is called contradiction. Now if it is combination of both, if it is a combination of both, what will be it? If it is combination of both, it is called as contingency. If it is the last column has all the values as T and F, it is called as contingency. For example, a contingency is a compound preposition. A contingency is a compound preposition that is neither always true, tautology, nor always false, contradiction. Its true value depends on the values of compound preposition. So here you can see in this last column, you have F and T, it is mixed. So whenever you have a mixture of T and F in the last column, it is called as contingency. What is it called? It is called as contingency. Here we can see so that now let example for disjunction. If you take disjunction, when it is F and F, it is F, remaining all is T. It is a disjunction is an example for contingency. Disjunction is an example for contingency. Okay, because we have a mixture of T and F, it is a contingency. Then you can take example as now if you prove a preposition, if they've given a preposition, we have to check whether it is a tautology, contradiction, or contingency. We can prove which is this. So let me check now. Here P Q, P implies Q, then negation q, and then p implies q and negation q. So here we have implies is what? T and f, it is f. So the remaining all will be t. Then negation will be f t f t. Negation of q is f t f t. Then we have to check in this too. Condition is and. So and is both should be t. We have both should be t. Yeah, here we have both are t. It is t. Remaining all it is false. So here is a mixture of all. So we can say that since the values in the last column is having t and f, it is a contingency. So here we have prepositions. Check whether the this inclusive or like expressions is a contingency. So let us prove. Let us check out what is the condition here. So here they have given p and q. Then we have first bracket, we have negation q, and then it is whole. First bracket is p and negation q. Then second bracket we have negation. You have to write it separately. Then you have to write this all together. It will be negation p and q. Then we have, I'll call this as 1, I'll call this as 2, and then we have this first and second bracket 1 or 2. So let us prove this whether it is we'll just check the condition whether it's a tautology or a contradiction. T T F F T F T F. So now negation q will be F T F T. So now P and negation Q. So we have to check in first and third one. And is nothing but T and T, it is T. We'll just see where we have T and T. Yeah, we have here T and T. Then we don't have other way. It is all false. Then next one is negation P. Negation P will be FFTT. FFTT. Now negation P and Q. So we'll be checking for this two lines, so that two columns. That is we'll check for the second one, and we'll check for this. The condition is and. The condition is and is again t and t, it is t. We'll just check whether we have t and t. Yeah, we don't have here. So the third one is t and t, so it will be t. The remaining all are false. Then now the final answer, to find the final answer, what we're going to do, we have to check the two conditions which they asked you to find out, that is 1 and 2. We'll just check in this box and in this column. We have to check for or is f and f, it is f. So let me check f and f, it is f. Then it is no here, no here. We have f and f, it is f. The remaining is t. So here it is a mixture of t and f, therefore it is a contingency. It is a contingency. So yeah, moving with the next question, we have proof that the given proposition is a contingency. Create a truth table using three variable and I determine if it is a contingency. So here they have given. We have to find. We have to find for P, Q, R. Then it is P or Q. Then it is P and Q and R. So yeah, uh, we can prove this. It is a contingency. Then it is this is not required. We'll just check for this. It is T T T, 4 times T, 4 times F. Then 2 times T, 2 times F. Then 1 time T, 1 time F. Then now it is P and Q. So we have to check in this P and Q, or is F and F, it is F. So here we have F and F, it is F, and here we have F and F, it is F. Otherwise all are. Now we have to check in this and this one, and condition, and is nothing but T and T, it should be T. We'll just check whether it is T and T. We have T and T, it is T. We have T and T, it is T. We have T and T, it is T. We don't have other way, it is false. So yeah, we can see the given table is having all true and false values together, so it is called as contingency. So this is not required. We'll move on with the next question. Now, prove that for any preposition P, Q are the compound prepositions. P implies Q and Q implies P implies P implies R is a tautology. Verify that the compound preposition P or bracket negation P and Q is a tautology. Show that negation P or Q implies P is neither tautology nor contradiction. Show that P and Q and negation P or Q is contradiction. Construct the truth table for P implies of P implies Q. P implies of, Q implies P. So these are some practice problems for you. You can just work out these problems by yourself. And this is some problems based on your exercise, whatever we have done. I want all of you to just to solve this. If you have any doubts or anything from here, you can just message me or you can write it in the comment box. I'll try to solve these problems for you. Now we'll move on with the next one. It is called application of prepositional logic. So we have applications of prepositional logic. It is used in many different fields. For example, propositional logic is a branch of logic that deals with the preposition and their logical relationship. It is used to analyze, model, and solve a real world problem using truth values. And in computer science, it is essential in programming, debugging, and designing algorithm. It plays a key role in digital circuit design by simplifying logical expressions using Boolean algebra. In mathematics, it is used to build and verify proof, especially in discrete mathematics. Artificial intelligence relies on prepositional logic for knowledge representation and decision making. It is applied in database queries using logical conditions and or and not. In legal reasoning, it helps in forming valid arguments and determining contradictions. Detecting contradiction. Software testing used prepositional logic to create logical test cases and verify correctness. Overall, it is a foundation. It is a foundational tool for critical thinking, automation, and formal analysis across many fields. So these are the some applications of prepositional logic. So yeah, next one we have application of prepositional logic. We use the prepositional logic to translating English languages. Just we have done these problems. We translate English languages by using the symbol and or, if and only if and if then and negation, and if and only if. So in previous slides, I've already explained you how to convert a statement into an symbol. The second one is we have translating English sentences. Will convert translating English sentences, that is, it is raining, then ground will get wet. P, it rains. Q, the ground get wet. So it is P implies Q. This is how we convert the English language into a symbolic way. This is one of the application for prepositional logic. Then you have system specialization. What is mean by system specialization? In system specialization is formal, detailed description of what a system is expected to do. In outlines, this system functions, behavior, condition, inputs, outputs, and logical requirements, often using prepositional logic and mathematical modeling to remove ambiguity. It helps the designer, developer, and stakeholders to clear understand how systems should behave in all possible scenarios before development begins. Why it matters: ensures clarity and consistency, prevents a miscommunication, acts as a blueprint for building and testing the system. So this is our system specification, a logic used in system specification. Then you have system specification example. Here you can take it as automatic door system. P, motion is detected. Q, door opens. So specialization using prepositional logic. P implies Q. If motion is detected, then only the door gets open. If motion is detected, then the door is open. Is an example for system specification. Then moving on with the next one, you have application. One more example: washing machine system. So you can take washing machine system. If power is on, door is closed, machine start washing. So how do we write in a specification? That is P and Q. If power is on and door is closed, then the if power is on and the door is closed, then the washing machine will start washing. So this is how we represent them in the form of system specification. So here it is safe and correct operating. If logic ensures that safety and correct operation. If it is the machine should not run if the door is open, even if the power is on. So these are some examples, real life examples, what we see in our daily life. Then you have a Boolean search. What is mean by Boolean search? Boolean search is nothing but it is a method of using logical operators like and or not to filter and refine search result by combining or excluding keywords, helping users find more accurate and relevant information. It is based on Boolean logic, where search terms are treated as true or false conditions in the query. For example, job hunting. You want a teacher job in mathematics, but not in physics. So mathematics teacher and job not physics. If you write shows only jobs for maths teacher, excluding any physics role. Then moving on, so here the second one is online shopping. You want to search a laptop of Dell or HP, you can write laptop and Dell or HP not refurbished. Lists will be produced by giving you the company Dell and HP laptops, excluding the refurbished items. Then research for an assignment. A student want to get information about climate change impacts on agriculture. So, but not related to politics. So if you write climate change and agriculture, not politics, you get the details what you required for the assignment. Then moving on with the next example, you have choose a project topic. So if you want to choose a project topic, the student want to explore artificial intelligence or machine learning, but wants to avoid results about gaming. So you have to write artificial intelligence or machine gaming, not machine learning, not gaming. We will be getting the result only about AI, artificial intelligence and ML, that is machine learning. It will in education, in healthcare, in business, not in the game development. So these are the how Boolean search help us to find the result. So next one you have is application is logical puzzles. What is mean by logic puzzles? You might see nowadays we can find it in newspapers, games, and other way. We'll be having a logic puzzles, games which will be made to use your brains and solve the puzzles. Brain games that required careful reasoning, deductions, and critical thinking to arrive to at a solution is called as logical puzzles. There they change the mind to follow clause, eliminate possibilities, and draw conclusions step by step, making them a fun yet powerful way to strengthen problem solving and analytical skills. They are widely used in education, interviews, and cognitive training to improve focus, logical reasoning, and decision making. So these are the some how it is logical puzzle, and some example how it has been created. For example, we can see classroom sitting puzzle. So we have to arrange the students sitting in the class. There are five students, A, B, C, D, E, sitting in a row. A sits to a left of B, but not next to C. D is between B and E. Find the correct order of sitting. Using in classroom or Olympiad to teach deducting thinking. So this is how they will be solving the problems by using logical puzzles. This is how they create the problems. The second one you have escape room challenge. So escape room challenge is a game or an app. In this escape room, a player must open the locked box with a three-digit code clause. The sum of the digit is 15. The second digit is larger. One digit is repeated. What is the correct code? This is how the puzzle is been created. Used in games, mobile apps, and real life puzzles to enhance the logic under pressure. So yeah, next one here we have see the next logical puzzle can be made in this way by animated pictures. Here, if one burger and one ketchup and uh, you have this 58, then one into burger is French fried. Then two ketchup bottles are 64. Then what is the value of one burger, one ketchup bottle, and French fried? Then the next one, logical puzzle is the same way. They can ask, you can create different types of puzzles by using a think different varieties of questions. So here, how to solve the logical puzzle? They've given this is about the Monday, Tuesday, Wednesday, Thursday, Friday. What are the sports you play, and what are the every year the town of Hipporville holds a week-long named tournament of games. This year, each of five residents won a different competition on different day. From the information, determine who won what when. You have to. They'll give you this type of puzzle will be asked. So these are the different types of puzzles which we can learn. The next one is application of prepositional logic is logic circuit. What is mean by logic circuit? We have like and or not electric circuit that uses the Boolean logic to perform our decision making operations. They are the building blocks of computer, enables machine to process information, perform calculations, and follow instruction automatically. Logic circuit translate true or false. One true means one, false means zero. Input into the specific output, helping device think and act in predictable, programmable ways. So here, these are there's some symbols which we use: or, nor, and, NAND, XOR, XNOR, buffer, and not are the logical circuits. So here we can see these are some values how it has been given for logic circuit, and it is 0, that is t, and t, it is t, that is written as 1 1 1 0 remaining. Or if it is 0 0 0 remaining all 1, then if it is not 0 1 1 0, nor it will be 0 0 1 and remaining all, it will be opposite of or. Then NAND will be opposite of and. XOR will be 0 0 0 and 1 1 0, that will be your if and only if and only if reverse of if and only if, then this x nor will be if and only if, that is a double implication, and this is implication. So these are some values which we write it in the form of circuits. So yeah, the tables and how the computer will be taking the terms in those computer system. So next one you have is yeah. Next is you can see even logic circuit can be made in this way. So where you have A, B, and nor and not is connected, and if A is 0 and B is 0, 00110101. X will be it is X will be 0001. If it is both on, then it will be on. Then for Y it is if both are off, it will be off, remaining it will be on. If both the circuits are on, it will be on, otherwise it will be off when both are off. If not, it will be all will be on. Then the final will be joining this two. We can write 000. If it is on or off, it will be on. If it is on or off, it will be on. If it is both on, it will be on. So this is how you get the logical circuits and their working. So some examples for circuit logic circuits. These are some examples. Determining the output for the combinatory circuit. This is a logical circuit which they have explained here by using and, not, or, nor gates, and how it gets the output is been given. Then logical circuit, automatic street light system. So automatic street light system logic circuit changes. It is dark light sensor 1. It is if their motion nearby motion sensor 1. Logic used dark and motion, turn on light. If it is dark and motion, it turns on light. Some examples for logic circuits determine the output for the combinational circuits. So PQR values are there. If P is off and Q is off, then P and negation Q will give you P and negation P or negation Q. So these are the values. The logical gate used in the circuits are used to apply prepositional logic. Here the input given to the gate are logic value variables P, Q and R. To apply the logic and not, or and or gates are used. Here AND gate taken P and Q as input and produces P and negation Q as output. OR gate takes P and negation Q and negation R as input and gives P and negation Q or negation R as output. So now we have logical circuits. Examples are automatic street light system. It is an example for logic circuits. For example, logic circuit checks: is it dark light sensor 1? Is there a motion nearby motion circuit sensor 1? If there is a light and motion sensor, it will give you 1. Logic used dark and motion turn on light. Only when both conditions are true, the light turns on. A simple AND gate logic is used in the automatic street light systems. Then you have ATM machine cash dispensing. ATM uses logic circuits to check card inserted, it will give you 1. Correct pin entered, 1. Sufficient balance, 1. It will check for these three conditions, and then the logic card and pin and balance. If all the three are on, all the three are if all the three are success, if it has 111, then it disperses the cash. All condition must be satisfied again, and the logic gate is used in this action. So these are the two example, live example, where logic circuits are used. So here are some problems for logic circuits. I had given you the examples and I've explained you how to do. I want all of you to solve this and send me a comment, or if you don't understand, let me know. We will solve this. The next topic is logical equivalence. What is mean by logical equivalence? Logical equivalence is a relationship between two prepositions that always yield to be the same truth values in every possible scenario. Even if the expressions look different, they behave identical under all combinations of a truth value. In other words, two statements are logically equivalent if they are always true or always false together, no matter the true value of their components. For symbol represented for equivalent logic is this three lines, and it can also be written as double arrow mark, which is used as a tautology. Here P double implication Q is a tautology. So yeah, then you have a quick example. We can just have a quick example. P implies Q is always logically equal to negation P and Q, negation P or Q. This is a logical equivalent example. P implies Q will be written as logically equivalent to negation P or Q. Both expressions are logically equivalent because they have the same truth values. Now, what is logical identities? So logical identities are establish rules and equivalency in a prepositional logic that helps simplify and or manipulate logical expressions without changing their true values. They act like a formula in algebra, allowing complex logical statement to be rewritten, optimized, or prove more efficiently. This identical forms the foundation of reasoning in mathematics, computer science, and digital circuit and automated proof. Key use: simplify logic expressions to prove logical equivalency, to design efficient digital circuits. So yeah, we have some logical identities, where we say logical identities is identify laws. P and T is always equal to P. P or F is always equal to P. Then domination law, it is P or T is T, P and F is F. Law of double negation, negation of negation P is P always. uh, Idempotent law is P and P is equal to P, P or P is also equal to P. Commutative law, P and Q is logical equivalent to Q and P, P or Q is logical equivalent to Q or P. That is commutative property for logical identities. Then you have associative property. In associative property we have P and Q and R is logically equivalent to P and of P and R. Then P or Q or R is equals to P or of Q or R. Bracket can be read as of. Then distributive proper laws is P and Q or R can be, P can be distributed for Q and for R. That is P and Q or P and R. The same way it will be for or and. Then you have De Morgan law. Negation P negation of P and Q can be written as negation P or negation Q. Then you have negation P or Q can be written as negation P and negation Q. If it is or for De Morgan, it will change to or, and if it is or, it will change to and. So this is called De Morgan law. Then you have absorption law, that is P or P and Q is equals to P, P and P or Q is equals to P. Then negation law, P or negation P is true, P and negation P is false. Then equivalent law, P implies P double implication Q is equivalent to P implies Q and Q implies P. So these are the identical identities for which you can draw the truth table and get the values whether they both the statements are equal. If they are equal, they are logically equivalent. So here we have it is next logical identities you have is P implies Q will be negation P or Q. P implies Q is logical equivalent to negation Q implies negation P. P or Q will be logical equivalent to negation P implies Q. P and Q is logical equivalent to negation of P implies negation Q. Negation P implies Q is equals to P and negation Q. P implies Q and P implies R can be written as a logical equivalent to P implies Q and R. That is distributive property. P implies R and Q implies R can be written as logical equivalent to P and Q implies R. Then P implies Q and P implies R can be written as P implies Q or R. Then P implies R and Q implies R can also be written as P and R implies Q. It is or it is written as and. If it is or here and, if it is written or, it is yeah and here. Then P double implication Q can be written as P implies Q and Q implies P. P double implication Q is logically equivalent to negation P double double implication negation Q. P double implication Q will be P and Q or negation P and negation Q. Negation P double implication Q will be P double implication negation Q. These are the some logical identities of laws of logic, which will be all this which I read now. You can draw the truth table for them and just justify whether LHS is equals to RHS. If LHS is equals to RHS, they are logically equivalent. And we represent logical equivalent by using these three lines. So we'll just see if we'll just prove here. It is a commutative law. So we can see here P, Q, P and Q, P, Q and P. We can see in both the case, both the values of this two, that is LHS and RHS are same. They are logically equivalent. Then you can go with the next one. You have De Morgan law. You can see here De Morgan law is what? If it is P and Q, it is T and T, it is T remaining false. And reverse of that will be T will become F and the remaining will be T. Now negation P will be F F T T, negation Q is F T F T. Now if you check for OR condition, OR is what? If it is F and F, it is F, remaining all will be T. Now we have to check with LHS and RHS. We can see LHS value and RHS value. Both are same, therefore they are logically equivalent. This is how you will be checking for logical equivalent. Then you have next one is, yeah, we'll just check whether it is a logical equivalent statement. So you have the again P Q. P implies Q is one side, negation P and then negation P or Q in the second side. So we'll just see P implies Q is what? T and F, it is F. Otherwise it is all T. And then what is negation P? It will be F F T T. And then we have negation P and Q. We have to check in this, or negation P or Q, or is F and F, it is F. So let me check. The second one is F and F, it is F. Then the remaining all is T. Now we have to check the values for LHS and RHS are same. We'll just check it. LHS is this P implies Q, and RHS is negation P or negation Q. So we can see it is both the same. The answers T and T, F and F, T and T, and T and T. Both the values are same. They are logically equivalent statement. You can say they are logically equivalent. So you can write here they are logically equivalent. So yeah, next one we have, you can see we have to prove this statement as logically equivalent. So here associative property, so we let me write t 4 times t and 4 times f, then 2 times t and 2 times f, and 1 time t and 1 time f. Now we have to check for and. What is the condition for and? For and it is both are t. The answer is t. For q and p, it is t and t is t. Then second is also t and t, it is t. Then you don't have anywhere, that is remaining all will be false. Then it is p and q and r. So we will be checking for this and this line. We have to check for and only. So we'll just see t and t, it is t. Then we don't have anywhere as t. So the remaining all will be false. So yeah, this is false. Then we have Q and R. We'll just check for Q and R now. What is Q and R? We have to check in this two. Q and R. T and T, it is T. We'll just see T and T, it is T. Then we have here T and T, it is T. Otherwise, it is all false. We have false for remaining ones. Now we have to check for P, that is P and this one. We have to check for this two. Condition is and is what? T and T, it is T. Otherwise, it is false. We'll just check with if it is T and T. Yeah, first one is T and T, it is T. Then second one is no. Third one is also no. Fourth one is also no. Fifth
P
is also
and Q and R. So we'll be checking it for first, that is P, and for the last column Q and R. So what is the condition? We have condition is and, that is T and T, it is T. So let us check for this T and T. We have T. Then we have second one is no. Third one we don't have. Fourth no. Fifth no. Sixth no. Seven no. Eight and no. So everywhere it is there is no condition where T and T is appeared. So the remaining all the values will be false. Since now we have to check LHS is equals to RHS, which is our LHS here. It is P and Q and R. So this is our this is our you can see. So this is our LHS, and the RHS will be this side. So we'll just check whether the values are same. Yes, it is T, and the remaining all are false. Therefore, it is a logically equivalent statement. So moving on with the next one we have. So yeah, we will be doing the next statement. Let me check for the next condition. What is that? Logical equivalent problem. Is this for the same thing with or? We have to check it with or. So yeah, let us prove. It is P. It is T 4 times T and 4 times F. It is 4 times F. Then it is TTFF. Then it is 1 time T and 1 time F. TF and TF. Then we have to check for for P and Q. Or condition is what? We have to check whether the both the terms are F and F. We'll get the answer as F. So we have F and F, it is F. Then it is F and F, it is F. Then we don't have other way. So the remaining will be T. The remaining values will be T. So yeah, the next one we have is I understand that this is a track next to our house, so I think you can hear the train going. Okay, so let us continue. Here we have P and R, P and Q, and P or Q or R. Now we will be checking for these two lines. We have or condition, so we will just check if it is F and F. We have F and F in the last line. Then we have nowhere. Then the remaining will be, it will be T. Now we will see for Q and R, that is second and third. Or condition, that is again F and F, it is F. Let me check wherever I have F and F. Yeah, we have here F and F, it is F. Then let us check. It is in the last line, F and F, it is F. The remaining will be T. Now we have to see for P, it is P, and Q or R. We have to see these two columns. Do we have what the condition is? Or we have to see F and F. We have F and F first, no second, also no third. We don't have fourth. We don't have fifth and sixth, seventh and eighth. We can see there is eighth. It is F and F, F and F. The remaining all will be T. The remaining all is T. The remaining values are T. One second. I'll just write it little clean. Yeah. So it is here we have it is F and F. The last one was F. The remaining values are T. So now we have to check for equivalency. So that is we have to check this line.
and for that is this, and for this line we have to check it is equivalent. Yes, yeah, it is both same, therefore it is logically equivalent statement. It is logically equivalent statement. Okay. Now moving on with the next question, we have check whether the given problem is now verify the compound preposition P and negation Q or R and P or Q and negation R are logically equivalent. So yeah, we will just check whether these are logically equivalent. It is T T T T F F F F. Then it is T T F F T T F F T T F F. Then it is TF 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 TF. Then negation Q will be FT FFTT FFTT FFTT. Then you have Q, negation Q and R. You have to check for or, that is F and F, it is F. So we have F and F here, so it will be F. Then otherwise you have F and F here, it is F. Then we don't have anywhere, so the remaining will be T. The remaining values are T. Now we'll check for P or and P and this column, P and fifth column. We'll check for and condition, that is T and T. So we have here first one is T and T, it is T. Then second, then third one is T and T, it is T. Then fourth is also T and T, it is T. Then you don't have the remaining one is false. The remaining all the values are false. Now we'll check for negation R. Negation R will be FT, 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 FT. Then we'll check for Q, Q and negation R. Q and negation R. We have to see T and T. Yes, we have second as T and T. It is T. Then third, fourth, fifth, sixth. Yeah, sixth one. We have T and T. It is T. Then the remaining is all false. So it is remaining all are false. Then the last one we have is P or. We have to check in the first one, P or, and the last line which we did now, that we have to check in these two columns. The condition is or. The condition is or is F and F, it is F. We have to check for condition F and F. So let me check if it is there, F and F. Yeah, we have. Yes, we have here F and F, it is F. Then we have in the last one F and F, it is F. Then the last one is again F and F, it is F. Otherwise it is all true. So the remaining is true. Now we have to check whether the both the conditions are same, whether the given compound prepositions are same. So we'll just check now. It is uh, we'll check for the value. This LHS and this RHS, are they same? No, they are different. So it is not logically equivalent. It is not logically equivalent. That means we'll just write it. It is not logically equivalent. Okay. That is P and negation Q or R is not logically equivalent to P or Q and negation R. So this is how we prove it is logically equivalent or not logically not equivalent. Then the next one you have is negation P implies Q and P or negation Q are logically equivalent. Let us check the statement here. P and P implies Q, that is T and F, it is F, remaining all are T. Then negation of this will be F, T, F, F. Then negation Q is F, T, F, T. Then we have to check in P and negation Q or condition, or is F and F, it is F. So we don't have F and F. We don't have second also F and F. Third one we have F and F, it is F. Then fourth one we don't have, just T. So it is all T, T, T. Now we'll just check if these two conditions are illogical equivalent. That is this and over this. So P and negation, sorry, it is for this. Negation P implies Q is equal to P or negation Q. No, this and this lines are not equal. They are having different value. Therefore, it is not logically equivalent. Therefore, negation P implies Q is not logically equivalent. P or negation Q. Then next one you have is here negation P double implication Q is logically equivalent to negation P and Q. P implies Q and Q implies P. Let us check if this condition is matching. Let us find the answer. You have here first is double implication. Double implication is it is double implication. So yeah, double implication say if both are same, the answer is same. Sorry, if both are same, the answer is T. If both are same, the answer is T. Otherwise, it is false. So what will be negate of this? It will be F, T, T, F. Whatever you got, reverse it. Then P implies Q, it is T and F is F, remaining all it is T. Then Q and P, implies P, we should go reverse. We have to see first for Q, that is T and F, we have here T and F, that is F, remaining all will be T. Then we have in this both, we have to check for AND condition, that is T and T, it is T, T and T, it is T. Here also we have T and T, it is T, remaining false. Now we have to check what is your negation of this, what we got. Negation only, this will be F, this will be T, this will be T, and this will be F. Now we have to check whether the values of LHS, that is negation of this line and the answer what we got are both same. Yes, they are logically equivalent. Since they have same value, they are logically equivalent. Then moving on with the next question, we have verify that the preposition negation P implies Q and negation P and Q are logically equivalent. Yes, let us check. It is T T F F T F T F. So yeah, implies is nothing but T F, it is F, otherwise it is T. The negation of this will be F T F F. Then P and Q is, if both are T and T, the answer is T. P and Q, the remaining is false. Then negation of this will be F T T T. Now we'll just check whether the answers are same. Here it is F and the remaining is T. The reverse will be F T F F. Then here and is T and T, it is T, remaining false. Negation of this is F and then this is T. So now let us check whether the answer in your LHS and RHS are same. Yeah, it is not same. If we can say that negation P implies Q is not logically equivalent to negation P and Q. So yeah, the next question is, you have next one, prove that the prepositions are equivalent. So T T F F T F T F. Then double implication, if both are same, the answer is true. Both are same, the answer is T, otherwise it is false. Then negation of this will be F T T F. Then negation Q will be F T F T. Then P and negation Q, double implication, T and T, it is T, T and T, it is T. Then otherwise it is false. Otherwise it is false. Then negation P will be F F T T. Then we have to check for P and negation P and Q. Negation P and negation Q. Negation P. No, it is not negation Q. It is for Q. We have to check for this two. This and this one. So here we have to see double implication. If both are T, the answer is, both are same, the answer is T. So we have second one is same. It is T. Then the otherwise it is second, next one is also T and T same. It is T. Otherwise it is false. So that is false. Then we will just check whether the LHS is equals to RHS. That is negation P, double implication Q, this. Then you have P implies negation Q, this. And then negation P implies negation Q, this. So we have to see the values are same for the all three. Yes, the first one and second. Mm, the second one is also same. Then you can see third and fourth. So this. So yeah, we can see that. One second. We can see here we have this and this and this and this and this and this is same. So we can say negation P implies Q is logically equivalent to negation P double implication Q, and it is not logically equivalent to this P double implication negation Q is not logically equivalent. Then moving on with the next one, we have here negation P double implication Q, it is T T F F, then T F T F, then P implies Q, that is if both are same it is T, otherwise it is false. Then negation of this will be F T T F. Then P implies Q, P implies Q, T F, T F is F, remaining all is true. Then Q implies P will be, Q implies P will be T F is F, the remaining is T. Then this both we have to find, and that is T and T, it is T, T and T, it is T, otherwise it is false. T and T, it is T, otherwise it is false. So here it will be T and T is T, and otherwise it is false. Now we have to negate this, it will be F T T F. So this we have to check for the condition where we have the first one, that is negation. Yeah, we have to check for this. We have this value and this value is same, yeah, they both are equal, therefore they are logically equivalent, they are logically equivalent statement. Yeah, then the last one, we have another one where we have they are proof, we can prove this by using the laws also. See here how to prove this, we'll just say you, here we have to prove negation of p or negation p and q is equal to negation p and negation q. So we'll just take the first one by the second De Morgan law. So yeah, and or will change it to and, that will be by using De Morgan law, that is negation p or q can be written as negation p and negation q. So we are just changing it by using the De Morgan law. Then negation p and this this negation is taken inside, so it will be multiplied for both as a distributive De Morgan law again. So and this and will change it to or. So negation of negation p or negation q, again once more we are using the double, that is De Morgan law. Then now negation p and negation of negation p is nothing but p itself. Wait to say what is it? Double negation law. Then this or negation q as it is. Now we are using distributive law and distributing it, that will be negation p and p or negation p and negation q, that is by distributive law. Then negation p and p is f, that is the complement law, or this will be as it is negation p and negation q. Now just reversing it, just writing this in the beginning. Now negation p or negation q or f is a commutative law for disjunction, therefore we can write it as negation p and negation q by identity law. So this but therefore they both are equal by logically, they both are logically equivalent by using the statements. Okay, the next one you have is here p and q. P and q is equivalent to p or q. So let me take that is negation of p implies q, p implies q will be equal to logically equal to negation p or q. So yeah, negation p or q. So we'll just take that by using this formula, implication formula we have just written negation p or q. Then taking the De Morgan law, negation p and q can be written as negation p or negation q, or this as it is. Then negation p or negation q will be we can take this as a commutative property, that we can write it as negation p or p and or negation q or q. So by using a commutative property we have just shifted. Now negation p or p is t and negation q or of q is also t. Then t or t is also t. If it is t means it is a tautology, therefore it is proof. And hence we complete the whole syllabus of this unit. For upcoming videos you can subscribe my channel. If you have any problem you can just write it in the comment box, or you can write a question to my channel so that I can solve for you. If you have any problem or any doubts you can message me. I'll try to solve them. Okay, I'll see you in the next video.